Thanks to Nolan, we all now know the story of Oppenheimer, the American Prometheus. He was a physicist, started giving lectures, and blew Japan.
Oh, come on, man. You can't say it like that.
I meant he ran the Manhattan Project with other brilliant scientists and constructed an atomic bomb to blow up Japan. He became quite a famous scientist after that. However, this video is not a lame scientific summary of the movie Oppenheimer. I'll wait here for a second so that we can see some more Robert Downey Jr. Here we will explain you how Oppenheimer predicted black holes. Before becoming the father of atomic bomb, Robert Oppenheimer was conducting studies in astrophysics. He was a theoretical physicist focusing on quantum mechanics. His third paper was actually explaining black holes before they were ever discovered. In his paper on continued gravitational contraction, he used the equations of Albert Einstein's general relativity theory to demonstrate how black holes could be born. This model shows the final stage of the evolution of heavy enough stars and is still being used today. Funny thing is, even tough Oppenheimer used the theory of general relativity. The father of this theory, Albert Einstein, was completing research showing that black holes could not exist. So, which of these two geniuses were right? To decide that we put Oppenheimer and Einstein to a cage for a fight to death. No kidding. Enough with the jokes. With our current knowledge and visual proofs of black holes, we of course know that Oppenheimer was right. The article states, in his words, "In this work, we will be concerned with stars which have large masses and which have used up their nuclear sources of energy. A star under these circumstances would collapse under the influence of its gravitational field and release energy." There are countless equations after this statement, which you will probably not understand unless you are a physicist. And if you are a physicist, don't watch this video to learn the subject, just go and do your own research. The important thing is, all these equations can be solved analytically with a pen and paper, and not require numerical methods. This means that the math of this study is quite simple but also complex enough to describe the collapsing stars. While Einstein was trying to destroy the concept of black holes in 1939, Oppenheimer was curious about how such object can come to exist. He asked his dear friend Snyder for help, and they discovered that this occasion is dependent on the observer's point of view. At some point to the collapsing stars, the wavelength of light would stretch by gravity, which is called a redshift, and the frequency would reduce from the observer's perspective. Thus, for the distant observer, the light would be frozen. So Oppenheimer and his colleagues demonstrated the concept of a stellar body so massive that its gravity traps light and causes infinite redshift to the world. Next question, why did Einstein think black holes were not possible? In 1915, he introduced the field equations to the world to make a series of different predictions, such as the calculation of Mercury's orbit. However, even Einstein himself did not think that these equations can be solved precisely. Only approximate solutions can be achieved. A German astronomer, Karl Schwarzschild, solved those equations and sent a letter to Einstein. Einstein happily conceded that he was mistaken after this letter, at least in this special case. According to Schwarzschild's solution, if you could compress a mass to a volume small enough, the geometry of the surrounding space would go haywire, and space-time itself would become infinitely curved. Let's take Earth, for example. According to Schwarzschild's calculations, we would need to shrink Earth to a radius about 1/3 of an inch. The resulting infinite curvature would prevent anything, even light, from passing this radius. Einstein, in his paper in 1939, stated that the idea of black holes is not realistic and did not exist in the real world. He focused on more pragmatic issues. He compared Schwarzschild's solution to the observations of Mercury's orbit. Even tough Oppenheimer and Schwarzschild demonstrated the formation of black holes theoretically. Einstein never really believed their existence. Can't blame him, actually. Stating that something may happen theoretically does not prove that it has actually happened. So who do you think is right? Einstein, Oppenheimer, or Schwarzschild? Not a real question. Don't answer that. Einstein was clearly wrong. Goodbye.